So my name is Reginald Augustus Raymond. So this is the medicine and this is a video for each task. So this is task 1 and I'm talking about the set builder notation. So in this part I had to describe 4 languages using set builder notation, and for each one first taught in plain English about what makes a string belong to the language. For example, for the first one, the set of strings over that begins with 1 and 2. So, a string only qualifies if it starts with the digits 1 and 2. Once I knew the plain English rule, I translated it into the formal notation. I did the same thing for at least one AD language, the exactly one language, and the positive or integer language. For the last one, the key idea is that number is odd only when its very last digit is odd. So I built a notation around the symbol, and this is it. So that's all for the A. So for the B, next I built three DFAs over the alphabet XY. So these are the three DFAs. This is 1, this is 2, and this is 3. One for strings ending in XY. This is the XY. And ending in XS. This is the XS. And ending in also YY. So, okay. And in JFlap, open a new workspace. And for each one, I use the same idea. One state remembers nothing useful yet. The second state remembers I just saw the first letter I need. And the accepting state means the last two letters matched exactly what I needed. The start state and then the final state. And then I tested it under multiple run and type a few strings that should be accepted. So moving on to JFlog. So we are going to draw BFA for XX. Okay, so 0, Q1, and Q2. So start mapping I, so X, X, Y goes here. Okay, I. Okay, so now we are going to set the initial state and the final state. So Q0 is the initial state, and Q2 is the final state. Final state. So we are going to test which one of the inputs. Okay, so first we are just going to input variables. So y, x, 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 y, y, x, 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 y, x, 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 y, x, x, y. I think this is enough. So then we're going to run input to see which one is being accepted by the machine. Okay, So over here, you can see y, y, x, x, y is accepted. Y, 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 x, x is rejected. Y, y, x, y, x, y is accepted. Y, x, y is also accepted. So y, x, y is also accepted. Okay, thank you. So then the DFAs are built over the alphabet x, y. 1, which is the x, y. 1 for x, x, and 1 for y, y. So with this that I drew in the J flap, this is a transitional table for the diagram for the DFA. So this is the starting state that it is which is a Q0. When it receives X, it points toward Q1. When it receives Y, it points towards Q0. Yes. Then Q1, when it receives X, points towards Q1. When it receives Y, it points towards Q2. Same applies for the Q2. When it receives X, it receives what? Q1. When it receives Y, goes towards Q2. Same applies to the XX. This is the transitional table. So this is the initial state. This is the final state. So with the initial state, you can see over here that when you're receiving X, initial state, when it's receiving X, goes towards Q1, and when it receives Y, come back to what? Q0. How the machine works. When it's receiving Q1, now you're on Q1. When it receives X, it goes towards Q2. When it receives Y, it goes towards Q0. And Q2, when it receives X, it goes towards Q2. Q2 is receiving X. When it receives Y, it's going towards Q0. With the YY, this is a transitional table for the DFA acceptance strings ending in YY. So this is the initial state, this is Q0, and the final state is Q2. So you can see over here that the initial state when it receives X is on Q0. When it receives Y, it goes towards Q1. And in Q1, when it receives X, it goes towards Q0. When it receives Y, it goes towards Q2. In the Q2, when it receives when it receives X, it goes to Q0. When it receives Y, it goes to Q2 itself. So that's all the SAX one. Thank you.